Evening, everyone. I would like to welcome everyone to this webinar hosted by SAIEE Power and Energy section. My name is Scebile Ntombela. I'll be host this evening. I am employed by Eskom Distribution, where I am tasked to ensure continuous improvement of plant, comply with current technological practices, safety standards, and desired operating performances. Today's session, we will be unpacking blockchain technology in the energy sector. Just before we continue, let's go through a few webinar considerations to ensure that it runs smoothly. Attendees are reminded to ensure the volume is turned up on their devices. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions pane located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. Chat function is reserved for webinar organizers and panelists to communicate with each other. Attendees will not be able to chat with each other, however, are encouraged to ask questions via the questions pane. The recording of this presentation will be made available on the SAIE YouTube channel, SAIE TV. The recording will also be made available on the SAIE website. Past presentations can be viewed on our website under the events drop-down menu in the section past events and webinars. This page is updated regularly, so to ensure you check back as often as possible for few uploads. And subscribe to our YouTube channel for more uploads. Our presentation for today, as mentioned before, is blockchain technology in the energy sector. Our presenter today is Engineer Esrom Mahlatsi. He received his master's degree from the University of Pretoria, South Africa in 2013. He is currently pursuing a PhD degree at the University of Johannesburg, South Africa. He holds the position of lecturer at the same university. His research interests are in the fields of power systems optimization, smart grid, stochastic programming, electricity markets, and transactive energy. Over to you, Engineer Mahlatsi.
Okay, thank you, Scebile. Good afternoon, everyone. Thank you, Scebile, for introducing me. My name is Esrom Mahlatsi, as she mentioned. I'm currently a lecturer at the University of Johannesburg. So today I will be highlighting some benefits of blockchain in energy sector. So today's presentation is a bit on a high level. The next coming presentations for those who are interested will be more technical. So I just felt I want to first introduce this topic, and then maybe we can get a group of people that will be willing to, to take this further. We form a committee that we can work together on this technology. So today my title for my talk is Utilization of Transactive Energy and Blockchain to Assist in Managing Load Shedding. So I'm gonna just run through the introduction, explain what a transactive energy market is, blockchain, how to apply blockchain to transactive energy, load shedding management, and some of the challenges of blockchain currently in the energy sector. So firstly, I just want to go through the history of our electrical grid. It's a very old grid, started in 1882. That was the first grid. Then around 1923, that's when Eskom was established. I have to mention that because we are in South Africa. Actually, the first transactive energy system was proposed in 1978 in MIT in the US. In the early 1990s, that's when the smart grid, they started formalizing the word smart grid, even though it was called healing networks. 1991, that's when the first blockchain was presented. In 2000, that's when renewable energy started gaining momentum. The renewable energy, they've been there with us for long, but they started gaining momentum in the early 2000s. The traditional grid, it's in transition. It's moving away from fossil-based to carbon-free sources. It's also moving from centralization to decentralization. So currently, we all aware how our grid works. You've got generation, transmission, and then distribution. And that's how power goes from top to bottom. So we are also moving from tyranny to democratization of the grid. So because now there's nothing much you can do. You are forced where you're supposed to buy electricity, who you can sell electricity to. So we are moving in direction where you are trying to get a point where you can buy electricity everywhere from anyone. So consumers can become producers. So if you've got a solar panel on your roof, you can actually sell that power. So now you are a consumer, but you can also be a producer. And then we've been trying to modernize the grid. The modern grid will actually be a smart grid, called a smart grid. How are we going to get that? One of the way we're going to do that is using demand response as a resource, because currently demand response is just one way of managing load. But I think it's about time we look at demand response as a resource of energy. So instead of generating energy, you can actually generate using demand response. Okay. Yeah. So this picture was actually taken from one of IEEE Power and Energy Resource Center. So this picture just shows us like our future grid, how our future grid is going to look like. So this grid is not from top to bottom. So you can see that there's a distributed generation everywhere. There's solar, there's wind. Actually, customer can sell power to each other. You can still buy power from the utilities. And then you now have what you call electricity market, but you also keep the traditional grid on the other side. So what is a transactive energy? So a transactive energy or market or a platform, transaction meaning that we have a transaction. So we sell something, so we exchange something. That's a transaction. So it can explain as a set of economic and control mechanism that allows the dynamic balance of supply and demand across the entire electrical infrastructure, using value as the key operational parameter. So basically, what we are doing currently, we are also there is a transaction between us and the utility. But the transaction that we're going to talk about is more the transaction between us as customers, us having transaction between each other, having transaction also with the utility, having transaction with everyone we want. And that's why I'm saying we want to have some sort of a democracy in the energy system, because the current system, like I said, is not democratic. If you stay at a certain place, the municipality that you stay in will supply you with power. You don't have a choice who should supply you. So in case, for example, the municipality is your enemy, so you don't have a choice. You're still gonna buy the electricity from your own enemy. So so this transactive energy will actually create an enabling environment for a number of users to partner with traditional providers to produce, buy, sell electricity using automated controls. So dynamic demand can provide cost-effective reliability, balancing, and load shaping support for the grid. So as I go further, you will see basically what you do here. So there should be an economic value every time when we transact between each other, but we transact in order to solve a certain problem. So this will also help us to integrate distributed energy resources. Like there's been talks on how can you put the solar panels on your roof. How can you integrate them to the grid? So this platform, the transactive market platform, will actually help you to do that a bit easier. So so because this transactive energy market platform, it's not necessarily there. There's something in Europe, they've got something in the US, but it's also on a, there's on a test phase. Like there's no one, is not yet being fully implemented. So that means here in South Africa, we are not really far off from them. So meaning that we start now, we're still gonna be able to catch up with them. So the only challenge that I've realized is that we cannot go and copy their transactive energy platform or market platform. We need to design our own that will suit our own need as South Africa. So basically it means that what they are doing in the US is not really gonna impact us. So we're not really gonna gain, from what they are doing. So we have to do something ourselves. So we need the framework. The framework is not there. That's where we start. So in the framework, we will try to define basically what is a transactive energy market in South African term. Maybe, for example, NERSA can actually have a definition of what is a transactive energy. They give a definition so that now when we work from the same point. You don't want to find other people doing something and the others are doing something. So the framework aims to provide a common view of the scope and a common vocabulary so that organizations working together or even in isolation can do so with knowledge that resultants of the system have a better chance of being able to coordinate their activities. So that's why I'm saying that first thing before we do anything, we will need to have some framework. And then after the framework, then we'll have the model. And then from the model, then we will have our own designs. And then we will have an implementation. Like I said, currently, we don't have any of the four. We don't have a framework, so we can't have a model design and the implementation. So in transactive energy, one of the most important things is that the customers can actually become the producers. So they are called prosumers. So what are the characteristics of these prosumers? So these prosumers, what they want, they have a choice of the buyer. Where do they want to buy the electricity? They will have a choice how much they want to pay for electricity. Like I said before, this is democracy. So you choose where you want to buy, you choose the price, and then so you will check if that's affordable for you, it's reliable for you. On the seller side, he's looking at profitability most of the time. But there are situations that we've seen that people that are well off, they might want to donate power to the grid or donate power to the poor. So they can actually, the seller can sell energy not to make profit, but just to help the community. The other thing is that this will help us to integrate our distributed energy resources, because if you follow this, when you start talking about you want to integrate these resources to the grid, there's always questions like, okay, you know, the quality of supply now, the voltages on the grid. So this market can help us do that, because there will be a point where we can actually sell to each other. We don't really need to go through the grid per se. The benefits of this system is that, like I said, it's reliable, affordable, sustainable, and it's very efficient. So, here the traditional utility, the traditional utility system that we have now versus this transactive energy system is that the traditional system, I see it as a tyranny. Like I said, there's no choice. There's nothing you can do. There's one supply, supplies you. It's a give or take. Electricity is a product that you get supplied with. On the other side, there's democracy. Like I said, you can choose where do you want to buy, how much you want to pay. Electricity is seen as a service, not a product in this new system. The utility is the supplier, you are the customer. All of us, we are Eskom's customers. So here in the other system, the customer can also be a supplier, and that's a good thing. The price is based on the production costs. Like basically what the utilities do, they want to recover their generation cost and then put a markup for profit. Here, price is based on value. So there's no price. You can actually pay 20 rand per kilowatt if you want. If you feel at that point in time that that's valuable, you really need this, you can pay that much so that you can have a supply. On the supplies from top down, so it's from the generation, go transmission, distribution, and then gets to you. So in the new system, the supply is bottom up. So the distributed generators on the demand side can actually supply. The utility set the price, non-negotiable. There's no democracy, remember. On the other side, the users set the price. So the users can actually tell you how much they want to, how much they are willing to spend to get electricity from you. So this new system, like I said, it's more democratic. So we are waiting for it. So the question is, this is a transactive energy system. So who are the transactors? So I just used the word transactors, but who are the people that will be transacting, doing these transactions? So the transactors engage in what we call an automated market platform. And then it has to be automated because when the blockchain will actually help you with that automated part. So as much as this talk, it's got I think the word blockchain gives the talk weight, but it's actually more about transactive energy. But what is going to make this transactive energy possible is actually the blockchain. That part of the blockchain will actually be able to give you this automated market platform. So the transactors can be the following. It can be homes. So you and your neighbor, you can actually sell. You can sell electricity to your neighbor. Office park can sell electricity to you. You can sell electricity to them. So as buildings, industrial sites, they can do that. Actually, I think even now, even in the current model, the industrial sites, at some point, they do sell electricity back to Eskom by way of, if Eskom doesn't have demand, they can ask the industrial site to actually reduce the demand. So by actually reducing the demand, it's more of selling that electricity that they reduce back to Eskom. So the other good thing with this system, your equipment can actually transact as well. So it's not just you, the equipment can transact, your geysers, your air condition, your pumps and your fans. So they can actually also be in the market. So if something goes on, your geyser or your air condition just react and then either buy or sell electricity to the to the grid. So without even, because now that will be automated, so you don't even need to worry, somebody needs to call you and ask you if you should do something. That thing, the blockchain will take care of that. Everything will be automated. Your distributed energy resources, so that means I can actually buy power from your solar panel. I can buy power from your storage, like if you've got a battery storage, I can buy power from there. I can actually buy power from your house as well. I can still buy power from utilities. Remember, it's democracy, so I can still go to the utility. Electric vehicle, I mentioned that. If you've got an electric vehicle, normally it's charged. You decided to take a taxi, it's sitting at home. Actually, we can buy that power from that from your vehicle. The communications between these are based on the price and energy quantity in a two-way negotiation. So you tell you send a price signal that, okay, I want so much power and I'm willing to pay so much, and there will be takers. Some people will take, and then you get that power. So it's always a two-way communication between the consumers. And we will show later on, because people will worry, how do we communicate? But we'll show how we communicate among us. So the price reaction approach, it also work on, like, you have to have flexible devices that you can, they can use some intelligent controller, like especially like if you've got an HVAC system at home, so it must have some intelligent controller that will be able to transact, with other equipment or with other buildings and stuff. In this case, this intelligent controller will probably be your smart meter. So now the question we should be asking ourselves is that if you already have a smart meter, is that smart meter blockchain ready? Because if it's not blockchain ready, then we are facing a problem. That means you already have a smart meter that you will need to actually replace with a blockchain enabled meter. Okay, this controller receives the price information and takes the device state and user preferences into account to operate local demand and supply resources. So I think as we go down, we'll show how you can use your HVAC system to actually transact, buy energy or sell energy. So now the question is this: who coordinates all these transactions? Who's supposed to coordinate these transactions? So currently, everyone says there must be a DSO, which is a distribution system operator. That must be there, that must actually make sure that coordinates all these transactions. So that DSO must be a grid operator and must be a market operator. And we find out if you're having actually a DSO, that becomes problematic. The DSO, the problem is that he's taking the democracy again. So there's no democracy, because you can't sell power directly to you cannot really transact as customers anymore, because if you've got power, everything must go to the DSO. The DSO distribute the power. The DSO set the price and then tell you, okay, I will pay so much for that. So we feel that the DSO doesn't really have a space in this new system. But the DSO can remain or should remain as a grid operator who makes sure that the grid is stable, there are no overloading of lines, and the voltages are fine. In that regard, the DSO must remain. But as a market operator, no. Actually, that market operator should be replaced by blockchain. Blockchain should take over as market operator. The DSO communicate with the transacting parties, and that's the problem. The problem with DSO in most cases, they are also utility managed. We are trying to move away from where we are controlled by the utility. So we are moving into a system that we can be partners with the utility, but we don't want to be controlled by the utility. The development of DSO is going to be very, very costly as well. This is due to amount of transaction which will drastically increase, because you must remember, when you're dealing with households, that means now your number of transactions will go with the excess of millions each and every day. Unlike the system operator now, the system operator, for example, now they've got very few, equipments like or few, not people, but zones that they distribute their power to. But if you want a DSO that is going to be dealing with all the households in the country, that system is going to be big. I'm not sure even if it's going to be manageable. So the DSO is somehow is the heart or the nerve center of the transactive energy, but we are trying to replace this DSO by actually blockchain. So the DSO will promote tyranny again in the grid, and what we want is democracy. So this is a picture. If you can look, if you have a DSO, so everyone, so the DSO is on the center of everything. So everything must go through basically the DSO. And one thing that we want to make sure, we want to make sure that customers can be able to transact among themselves without an interference of the DSO. So how do you transact? Like, what there are different schemes that you can use to have transactive energy. You can honor bilateral transactive bids and offers. So there are people send bids, you take them, or offers, you decide whether you want to take them or not. You can react to market price signals if you are dealing with markets. You can participate. Remember, you are democratic. You can participate in markets. If you see price signals, you can only react to operators' instruction depending on your agreement with the utility. So if you've got an agreement with the utility that, okay, you can call me anytime and I will do something on my side, that's also fine. So it depends on how you set up your system. And that's a good thing about this transactive energy system, that you can work anyhow that you see fit. So now we want to apply blockchain to transactive energy. Like I said, the main thing that this blockchain does in the whole system is to actually give us that democracy, that we can actually transact amongst ourselves without the DSO. So what is a blockchain? A blockchain is a distributed database of digital ledgers that records transactions of value using a cryptographic signature that is inherently resistant to modification. And I'm thinking that, I hope that people didn't, when they came to the talk, they thought we're going to be talking about Bitcoin because they see blockchain. The most successful story of blockchain application is actually the Bitcoin and the other cryptocurrency. But a Bitcoin is actually an application of blockchain. So they are not synonymous, but we have to agree that Bitcoin actually made this like blockchain to be very, very popular. What is the myth? The myth is that the blockchain was designed for cryptocurrency. That's a myth. That's not true. Blockchain was invented in 1991 by Stewart and Scott with the aim of cryptographically linking blocks in an appended data structure by storing hash values that are timestamp blocks on the blockchain. So they try to have a digital signature that you cannot change. So for example, if you get a degree at University of Pretoria, we can actually put a stamp on it, and then everyone in the world will know that, okay, you got the degree from this place. So you cannot really go and fake that degree because that thing is digitally signed. So this would prove that a document exists at a certain time and in certain version. So that's what the blockchain was designed for. So in 2007, these guys who came with the Bitcoin, actually they used blockchain to design a Bitcoin. But a blockchain, it's a mother to Bitcoin. A blockchain is the internet. A Bitcoin is just email. So you need the internet to access your emails. What is the good thing about blockchain is tamper resistant, so you cannot change it. Why is that important in the system? So now, if now me and you are transacting and you sell me power, so you cannot go and sell another one. It will be impossible for you to sell another one because it will already have recorded that you sold that power to so and so for this much. So you cannot change it. And that's what we want. It can, like during when there are faults, it doesn't stop running. It can run up until you fix the fault. You can verify the data of any participant. If a person tells you that, okay, man, I've got a solar farm somewhere, it's producing 2 megawatts, you can easily verify that data. The blockchain will be able to verify that, well, this guy is telling the truth. He's got a solar that's actually producing this. So it enables also transparency of transactions, between each other. So in whole of this system, the biggest problem will be the trust issue, and blockchain gives you that they solve the issue of trust. So you know that even if you are sitting in Joburg, somebody in Cape Town wants to sell you power, you don't have to worry because you know that either he's got this or he doesn't. The good thing, blockchain eliminates the middleman. The middleman in transactive energy is the DSO. So the DSO as a market operator is the middleman. We don't want him. We want to remove him. So non-blockchain transaction typically involve a centralized server to validate and confirm transaction updating a secure ledger. So basically the biggest problem with that, the minute you are using a DSO, the other problem is that you're not actually even going to be paid immediately. Unlike in the blockchain system. The blockchain system, if you sell me power now, you get paid now. So in the DSO system, the system operator needs to consolidate all the accounts and then later on send you money. We don't want that. So if you sell me power at 5 o'clock, at 5 o'clock, the same time you get your own money. Blockchains do not require trusted parties to validate and confirm transaction. They rely on a process called consensus, which removes the need for DSO. Consensus is a set of rules which determines if the transaction is valid or not. Let's say now you want to buy power from someone in Cape Town, but you actually don't have money. Then blockchain won't allow you to do that, won't allow you to buy because you don't have money. What are you going to pay? If a transaction is submitted which does not comply with the consensus rule, then it will be rejected by the blockchain. So if a bad actor attempts to introduce a transaction or a block that does not comply with the consensus rule, the other node will reject the block. So if somebody now, he wants to claim that now he's got more power than he actually has, then the blockchain will actually reject that, because also the blockchain will be monitoring the smart meter that you have. So there are disagreements. There can be disagreement, but the consensus rules may result in what you call a fork. So you always need a 51%, because there will be a lot of nodes that have to validate a certain block. So you will need for 51% of those nodes to agree with a certain transaction. So, like I've been mentioning, one other good thing that blockchain is giving us is what we call peer-to-peer transactions. So, like I said, now you can transact to anyone. So, peer-to-peer energy trading is the use case that is gaining most traction. This is being made possible by the ability to pre-program what we call smart contracts that can trigger transactions automatically. So you can actually sign contract with people using blockchain. Those contracts are called smart contracts. We must mention that smart contracts are not legal documents, are actually just a piece of code that it's stored in the blockchain. So if something happens, you sign that, so you will be able to transact automatically with anyone. So you don't need to, no one will come and bother you. So you will either see, if you are a seller, you will just see money coming in without you worrying or what happened. One of the most obvious and powerful uses of digital ledger technology is to provide a reliable, efficient platform for executing and recording transactions. With blockchain, transactions such as energy trading can be recorded and settled almost instantly with no need for intermediary and with a little or no need of reconciliation, since all parties are using the same platform. So depending on whichever cryptocurrency you will be using, so like we said, so all of us will be using the same system, the blockchain. So that's the reason why when I sell you energy now, actually I get paid immediately. So there's no one to reconcile, and that's good. That's what people want. You know, people don't want to wait for a week for their account to be settled. Okay, in terms of the contract, creating a smart contract that automatically validates your transaction without the need of human interaction. So actually, that's one good thing that this blockchain actually brings. If you are dealing with the DSO, there are things that you need to sign with the system operator. And in the system where you're using blockchain, you don't. You will do probably everything on your phone or your laptop or any digital device that you might have. A smart contract represents a digital protocol that automatically executes predefined process of a transaction without requiring the involvement of the third party. So you can set that whenever I'm not at home, I want to sell power from my solar panel. And then you set that in your smart contract, and then that will happen every time you leave your house, that will happen. So here I'm trying to show you a system where you are actually trying to transact with the market. So this study was done by the Pacific Northwest National Laboratory in the US. So basically here, what they're using HVAC system to transact. So how do they transact with an HVAC system? So normally with your HVAC system, it's got a set point. So if it's got a set point, so if you move the set point, depending whether you move it up or down, it will actually change the energy consumption. So if you move it one side, it might start consuming more, and if you move it the other side, it must start consuming less. So for example, if you are in South Africa, you are on what you call a cooling mode, and then maybe your set point is 23. That's how you like your temperature. It's at 23. And then now something happens, somebody wants to buy that electricity from you. What will actually happen is that your HVAC system will move from 23 maybe to 25 or 26. So it will start consuming less. So by actually consuming less, it means you are selling that power to whoever wants to buy. So now you can see a system where your demand response is actually generation. So if you need power, we need power. My neighbor needs more power. He doesn't necessarily need to get more power from the utility. He can actually just get more power from me. I can just give him more power, and then there's a contract between us, and then he pays me. So basically, that's what happens here. So you've got the TE, that's your transactive energy, and the blockchain, and then you use that. Everything obviously will be over the internet, and then it goes on the other side, and then it helps you to alleviate distribution congestions or transmission congestions. So here it's a typical graph for an HVAC system. So on this system, what you actually have, you have a desired set point, which is a 72, and then you've got between your set point minimum is 67 and your maximum is 77. So that means any temperature there, it's allowed. Like you can take any temperature there. So you are at 72, you get a signal that somebody needs power, and then you can move to another temperature. Let's say you move to 75, and you sell that power that you will gain from moving from 72 to 75. And then you are sitting at 72, and you realize that no, somebody is selling power cheaply. Let me actually buy that power from that person and move a little bit down to lower temperature, because if you are at lower temperatures, you will actually get to your set point quicker. So this is either you call it a pre-cooling. On the other side, even the heating is the same thing. If you want to get to the certain set point and you want to get there faster, you must heat above that temperature. So here is the same thing. So here you can decide either this equipment, this HVAC system can decide to either buy or sell power. The good thing with the blockchain, this whole thing will happen automatically, because you would have set all your terms in your smart contract that sit in the blockchain. So you don't have to work. So you can change the terms of that contract whenever you feel like it. So I said you can actually use that system of transactive energy into actually help you to deal with the issues of load shedding in the country. So we all know what happens in the load shedding. It's a matter of supply and demand. So what happens, you've got more demand, less supply, so you need to shed the demand. That's what our utilities do. So if there's a shortage of supply, they will actually want to cut the demand. And we are well aware that there also are some contracts with other big companies that actually they can ask those companies to reduce also their demand in this case, but eventually we get shared on the other end. And here we are talking about the global load shedding, not the local load shedding. So the local load shedding will be the one that happens because the municipality infrastructure, it's got problems. So that's actually a local load shedding. We are talking about the global load shedding from the Eskom side. So we all know how these stages work. You've got stage 1, 2, 3, up to 8. So on stage 1, you need to shed 1,000 megawatts. But now here we need to understand this 1,000 megawatts. You can shed this 1,000 megawatts anyway. You know, there is no specific place that you actually should shed. You can shed anyway. But if you look at your NRS standard, it will dictate that no, you need to shed everyone equally. So you shouldn't discriminate. So people need to be shed equally. So that means eventually all of us, we get shed in a day. If there is a load shedding the whole day, everybody gets shed the whole day. You have to get shed at least once. So this problem, what causes this problem? For example, there is no retail price signal that exists today at a scale to alert customers of load shedding or blackouts as they occur, incentivizing them to modify their behavior to help alleviate the problem. So basically what happens now, if there's load shedding, Eskom will advertise on TV, please guys, there's load shedding, cut your supply. And most people don't honor that. I think probably I'm the only person who does that. Like when I see that message, I normally switch off some of my appliances, but I know you guys don't. So that's the problem. So now we have to design a system where the people or the equipment that actually switch off, we give them some sort of an incentive. And by so doing, Eskom on the other side they won't need, to shed anyone. So in this case, when this case happens, when there's a shortage of supply, instead utilities or Eskom in this case try to shoulder the full burden of grid balancing, relying on dedicated infrastructure and reserve capacity contracts, some costly investment with low utilization factors. So like if there's a shortage of power, they try to generate more on the other side to try to meet that demand. But that kind of a system, we know, first of all, it's not efficient. We are talking about 25, 30% efficiency. So what happens in this case with a blockchain? We are saying that we can actually be in a system where you transact with as many equipment. Like in your house, we can transact with only a washing machine, for example, in your house. So when there's load shedding, we switch off the heating element of your washing machine. Everything is still fine. You still have TV, you have everything. And then we do that. Next door, we switch off, we change the set point of the aircon next door. The next guy, we change the set point of the fan. By so doing, we are actually reducing the consumption, but nobody has to be shared. And whoever we are taking this power from, that person is selling the power, so he's getting incentive. We are buying the power from that. So Eskom as a utility can do that instead of trying to keep what they call reserve margins also to cater the evening and the morning peak. They might decide, no, they don't want to have those margins, and in the morning they just buy power from people. So people willingly says, okay, fine, we are willing to sell so much power. They sell that power, Eskom buys it. And that is actually because when you buy power like that, the efficiency of that is 100%. But if you are trying to have a system with reserve margins, the efficiency of that system, we are talking about 25%. So I gave this example. If you stay in Silver Lakes, for example, if I could choose any place, you are at load shedding stage 1. We need to shed 1,000 megawatts. Right? So this it's what happens. So with this transactive energy and blockchain, the people or the companies that are in Silver Lakes can decide, or okay, they don't want to be shared. But now, if they don't want to be shared, something must happen because 1,000 megawatts must leave the system. So this thing, through transactive energy and blockchain, they can actually buy power from other areas, and then in so doing, they won't get shared. So when you buy power from other people, so majority of the time, so you don't really want to buy power from one area, like even if it's one area, but not like the whole power. Like if you are buying power from a household, it will bind a certain portion of that power. So whoever sells you power, you will still have power, but he sold you some portion of that power. So in that case, you're not gonna be in a situation where there are robots that are not working because we shared the substation. Because what this system will also remove this issue of Eskom shading you from the substation. So here now you have a system. So people in Silver Lake said, okay, guys, we can buy power from the guys in Mamelodi, right? So the guys in Mamelodi, so say, okay, people in Silver Lake, you want to buy power from us, how much are you willing to pay? And then this guy says, no, we are willing to give you 3 rand per kilowatt, for example. Remember, this is democracy. That price can change. The people in Mamelodi can say, no, you guys are from Silver Lakes, we want 10 rand per kilowatt hour. And then the people of Silver Lakes, because they have money, they say, okay, fine, 10 rand is fine. And let the people in Mamelodi shared that 1,000 on their own willingly, and everything goes well. But the good thing with this kind of system is that things like robots, hospitals won't be shared, because the people that are sharing, like one person will be, like I said, will be just switching off the stove. Some person will be switching off the lights. Some person will be switching off a TV. So, and you are getting paid. But how is that going to be possible? So this will be possible because of blockchain, and because this, everything will be done automatically. So you don't really need to call somebody. You don't need to call, contact any system operator. So you just you just switch on the system if the system was off, and you start transacting. But most of the time, you will actually have these scenarios as well within your smart contract. You would have gave these scenarios. So in terms of load shedding, and I'm supposed to be shared, I don't want to be shared, I want to purchase power. So people can look, people who know this place, it's Silver Lakes and Mamelodi, they are very close. But in actual fact, the people in Silver Lakes can actually still buy power from somebody in Alex, because it's the same system. So if you want, like, it doesn't matter where you take off this 1,000 megawatts, as long as the 1,000 megawatts, they are out of the system and the grid is balancing. That's what the grid wants. But now the system that we are having, you find a situation where Centen, it's being shared, because it's on the schedule, it's supposed to be shared. And the NRS tells you that, no, you actually have to share everyone equally. You can't discriminate. Centen is the economic hub of the country. It doesn't make sense for us to share Centen. So in a system like this, most companies in Centen have money. So they will actually buy power probably from the guys from Alex. And the guys from Alex, majority of these guys, they are poor, and they will be happy to sell these guys. And everyone is happy. The guys in Alex are getting money. The guys in Centen have power. And then we move. There is no any disturbance to the economy of whatsoever. Because even if a company decides to say, okay, I'm willing to shed, that company will be compensated. So it's not that company will be losing any revenue. But the current system, what's happening is that, hey man, sorry, we want our 2,000 megawatts if it's stage 2, 4,000 if it's stage 4, and then that's life. So we are saying that this system, obviously it's a futuristic system, but we think this will solve almost half our problems. Obviously, like any other system, the system will have challenges. As you've seen, that means all the meters must be smart meters, must be actually a blockchain enabled smart meter. We don't have that. We are struggling actually just to get smart meters currently in most places. You know, there's a township we won't mention by name here, but we know they don't want smart meters. So what are the challenges to this system, to this blockchain and transactive energy? First of all, there are a lot of challenges. So I just mentioned some. There's a lack of policy. And NASA can give direction, can give leadership in that regard. There's a lack of common framework. This is where we start, and that's why I decided to try to give a talk in a very high level, because I want us to come together and formalize this framework. I told you, we're not going to get this framework from Europe or the US. It's impossible. Me and you have to sit down and draft this framework. Some challenges, they are resistance to change. And most likely the two people that might give us issues might be DOE and Eskom. I'm saying might be DOE and Eskom. For example, I know Eskom on the distribution side, I stand to be corrected. They are trying to build DSO, a distribution system operator. We still need to sit down with them and see what are the boundaries, what are they trying to do there? Because let's say, like I said before, I indicated, if it's a grid to be a grid operator, that's what we want. But if they also want to be a market operator, that all the renewable sources they going to give them power into their market, maybe that's not going to work. There's also a matter of skill shortage in terms of both blockchain and transactive energy, but I think we've got enough universities that can actually help with that. So there's also there will be a huge amount of data, and that's what people are worried about. Some critique of blockchain energy, actually, they keep on mentioning that you know, the amount of data that you need, it's just too much. We might not be able to store it. But I'm saying that in next 5 or 6 years, you know, I know there will be an innovation that will actually solve that. There's the issue of networks. If you want to use the internet, maybe when we've got 5G, it might be better. You've got an issue of scalability, which this problem of scalability emanate actually even from smart grid, because that means you've realized that if your geyser or your aircon needs to transact, it must be an enabled equipment. So it now starts to show that even our equipment needs to change. So basically all we need what we call smart devices. And the smart devices, they have been explained, like in the framework of a smart grid, they are smart devices, or what they call smart loads. Okay. So obviously what we are trying to do here, this obviously, it's if you look at it, it's actually a smart grid. It's how the smart grid is supposed to operate. The smart grid is called what? A self-healing network. So a self-healing network, or if there are challenges in the network, there's a shortage of power, example, in terms of load shedding, the network heals itself. The network doesn't wait for Eskom to do something. The network will actually heal itself. So what is the future work? Obviously, we still need to sit down and talk, especially people that are interested in the technical side of this. We must form some committee on blockchain and transactive energy. And like our first job is to draft that framework. We need to have some discussions with NASA regarding the policy change. You know, it will be good if maybe they've already been working on something. We also need to sit down and discuss this necessity, whether we need this DSO or not, or if the DSO is there, how should it operate? Because I had discussion with other people who are very excited about this DSO, but I was not so excited the way they wanted to work. We need skill development, so we will need to get some PhD students and master students to work on this thing. And that's also for me, if you also want to build this DSO, first of all, the skills you need to build it, you will need a lot. You will need a lot of technical ability to actually pull it off. So we are actually working on a journal paper on this for guys who are actually interested on the technicalities, because I know there are people that want technical. Maybe this was at a very high level for you, but don't worry, we will still deliver the technicalities of the whole thing. In my conclusion, I will say distributed energy generations are the future. That's how I see us going. I see us buying more power, generating more power for ourselves, buying more power from our neighbors, buying cars from cars and everyone. So there will be some sort of a reduced demand, like from the utility side. And the people keep on asking me, am I saying the utility is going to die? Not really. The utility can actually just change their business model, do other things, or work with other clients, other loads. If we build, let's say we build, I don't think now where we are we can even build 2 or 3 smelters. We won't have enough power to supply those smelters. So in this case, if we are buying as consumers, like household, we are buying, generating energy ourselves, we can actually free that energy that Eskom, for example, can supply to some big clients to actually further the economy of the country, which is a good thing. So depending on how the utilities will react, but if they react in a way, they might find themselves on the receiving side, but they should still have a role to play. Solutions for load shedding lies definitely on the demand side, not on the generation side. So I see load shedding as a demand problem rather than a generation problem. And for the longest time, we see this as because most of the time what will happen, generators will trip, now we go into the load shedding. So that's why we see it actually as a generation problem rather than a demand side problem. Utilities should look into altering their business model. One way, for example, definitely they need to be network operators. So they must operate the network. So they can actually charge a fee. Actually, in this system, if you look in this transactive system, the utilities, most utilities should just charge a fee for you to use their network. Transactive energy and blockchain are the centerpieces of the smart grid. So this one will actually complete the smart grid because, like I said, there is not the transactive energy and the blockchain will only work on smart loads with smart meters that are blockchain enabled. So yes, so this is actually what I had for today. But like I said, I think I will get feedback, and the people who want to work on the technical side of this, they will contact me, and then we will take it forward. For example, students, I'm looking for master students that can work on this. There's actually one student that is busy working on something like this, but we will do if we can get more students to work on this on these systems. So if I checked a lot of material. If you are IEEE member, especially PES member, you can check under their PES Resource Center. They have a lot of material. But this magazine, this Power and Energy magazine, will actually give you a very good background on transactive energy, even though it doesn't have the blockchain, because they are also using a DSO, but it will actually give you a good background. This one I should be able to send you. I have a copy for that magazine, so if you contact me, I can send you off. These PNNL, you check them, they've done a lot of work on transactive energy and blockchain. And then you've got this organization called Gridwise. They've got a portion of it that they're just focusing on transactive energy. So that's where you can actually get a lot of material. For start, I will say go to that website, get that IEEE Power and Energy magazine. Yeah, that should be actually a start. So for now, I'll be willing to, I hope you send some questions. Some questions we can take it offline. And yeah, thanks for listening.
Thank you very much, Engineer Mahlatsi, for a well-delivered presentation. It really came out how passionate you are about the topic. In the interest of time, we'll only take 1 or 2 questions. I see we have quite a number of questions, but I want to assure all the attendees that look into all questions. If we can't take all of them now, we'll definitely respond to them and post the responses on our website, which is SAIEE website, and also on the SAIEE YouTube channel. So the first question is asking, municipalities become prosumers. Can you respond to that, Esrom?
I didn't get that question.
Would municipalities become prosumers?
Yes, definitely. Actually, that's long overdue. Municipalities should have started a long time ago to actually produce some of their energy, because, for example, all municipalities, they run a sewage plant that they can actually generate a sizable amount of energy, either to use on the same plant or even send it somewhere else. So they were supposed to be prosumers. I think Tshwane, city of Joburg, they are actually prosumers. They actually generate something for themselves.
I'm also getting messages that says they want to be part of the working group or team that will further explore this, so that is very interesting. Another question says, for clarity, in South Africa, PESA sets the price, not utility. It's actually not a question, it's just a clarity.
It says
I
what?
think it says that it's NESA that sets prices, not utility. You spoke about you determine your own price in your presentation. I think it's referring to that.
Yeah, no, we know that. We can take it offline, or who actually determines the price. Yeah, it's NESA. Yeah, on paper it is NESA, yes.
Okay, I will take the last one. During stage 1 load shedding, we will ensure that there is in fact power reserves available.
So is that a question?
Yes, actually it says during a stage 1 load shedding, we will ensure that there is in fact enough reserves available at the time.
No.
How will people know, or is it the system gonna notify you that there is power available on the system?
Oh no, your meters. Remember your meters, your smart meters. They will know that, because they will have a frequency sensor. So they will sense the frequency of the grid when it's going down, and they will start reacting. And remember, your smart contracts are automatic, so everything will just open in the background. So the system itself, your geyser, will know that there is load shedding, and it must act the way you set it to act. And then your solar panels, they will also act the same way. So you don't need to tell it. There's no one watching it, and that's a good thing about the system. The system itself will take care of itself.
Okay, thank you very much again, Engineer Mahlatsi. I will now, in the interest of time, would like to thank everyone who attended this webinar. Please be on the lookout for the next upcoming webinars. Make sure you tune into our YouTube channel, SAIEE TV. Go to YouTube and search and like, and also go to our SAIEE website for this recording of this webinar, which will be posted there, and also the answers to the questions, and also other upcoming and previous webinar videos will be posted there. Thank you again. From me, Engineer Scebile Ntombela, goodbye and good